I think this is a 72, as I recall. Triumph T120, 655 speed. A real nice original bike. Clients owned it for a lot of years. And we're going to put an electronic ignition on it, a solid state charge system, and it's got a brand new Premier carburetor on it. We might just look at it, but we're probably not going to do anything with it. See if we can't get it started. Clutch is slipping, we're going to replace that. That's on order. And see about running the cables a little differently. And right now the biggest problem is that this bolt inside the tank that holds it in is rusted, and the whole bolt is turning rather than just letting the nut come off in order to remove the tank. So that's a challenge. And we do want to take it off because we're going to go in there and change the coils for the ignition system. And then we just lifted the seat and looked underneath the seat. Yep. And oh my goodness. Oh my. Well, we're going to do some serious cleanup here. Yeah, this is just lovely. Okay, so we'll do some serious cleanup on that wiring, and we're not going to try to make the bike look pretty. I mean, seriously, this is character. Okay, I don't mind that. We'll just make sure that it's electrically okay. We'll clean up those wires. So right now, we really want to get the tank off so we can get up underneath of it. And if any of you have clever ideas of how to break free a rusted bolt, rusted nut on the shaft bolt that is supposed to be locked at the bottom and not turning, but does, feel free to comment. I hope by the time you have the opportunity, we have it broken free. We'll find out. And the fun just never stops. All right, we just did some seriously cool work. Honest to gosh, it was a job like you wouldn't believe to get this tank bolt out. Here's the residual, the piece that's here left. There was this, apparently this little guy was used to hold it in or something. You can see how the this whole area is roached. We'll think of something to do something. We'll do something better when we put this back together. Okay, so here's the bolt. Let me show you over here. This is the nut, and here's the rest of the bolt. And what we did is Kevin got down inside of the tunnel with these, enough to slightly hold the nut to keep it from turning, the whole thing from turning. And we were able to, while he was holding it, I drilled down the center of the bolt with small, larger, really small drill bits all the way down into the bolt. Each time a little bit larger, a little bit larger, a little bit larger, until this part broke off, leaving this part on the remainder of the bolt. At which point we were able to take a 9/16 wrench, of which I have one nowhere, but it's just for you. And Kevin was able to get down inside the tunnel onto the nut sideways. So I was able to come down with a 1/4 inch drill and go through the nut and break it free. So it was an adventure. We decided that after 2 or 3 attempts that if we didn't think we could do it safely, we were just going to say, sorry, we're not going to do this job because we're afraid of damaging the gas tank, of which we didn't do. It's a mess in there. You can see all the shavings. See if I can get the focus to focus. I guess not. Got to figure out how to do that. Anyway, you can see it's a mess in there. And so we got the tank off. So I can get at this wiring, double check it, cleaned it up, and do whatever we have to do for installing the new coils, which are actually back here. The solid state rectifier, which may go back here, and the boiler box, which will probably come back here, all of which saying you really didn't need to take the tank off, Frank, but the client wanted the tank off and wanted that bolt undone, and we did, by goodness, undo the bolt. So we'll come up with a better way of putting that tank back on. So that's it for now. We will now start ripping and tearing wires and coils. All right, it's about 5 to 11. I didn't get a time hack on that last video. I'll have to go back and check. We've got both side covers off, so we can get in here and get to wiring and bits and pieces and whatever this broken piece is from the old blue capacitor. Get that out of the way. All this wiring is clipped and cut off. We got to get this little rectifier out of the way. We're going to do that now. And then this. Basically, we're just going to do some cleaning up in here. And new hoses. And stuff. Here's all the stuff we've taken off so far. So, well, it's 12 o'clock. It's lunchtime. I'm hungry. I'm going to take off for a little while. Get myself a hamburger and some fries. Something greasy and not healthy. All right, let's go down here. Got the bike's wiring stripped out from this area. Stripped out and somewhat cleaner. Ready to put in the ignition and the new regulator rectifier. And I might touch some of this up with a little black paint just for the heck of it. I'm looking at all these wires hanging out thinking, gee, I wish I had a wiring expert. And I said, oh, wait a minute, that's me. Okay, never mind. So anyway, everything's stripped out to the point where I can start putting it back together. Kevin had to go home, so I'm here working on bits and pieces. Take a lunch break, come back, and put some of this stuff back on the bike. Well, hello. It's 3:30 in the afternoon almost. I'll close up here. The what I refer to as center of bike wiring is complete. Everything's run. This is the ignition wire that's going to go to the ignition box. This is the charge wire from the rectifier that's underneath the battery box here. New battery pad. This flasher may or may not be changed out depending on whether we go with LED turn signals and lights. These are your common grounds. They will all be hooked together and go to the battery and go to a nice firm ground point to ground the whole electrical system. I've got a new wire going down to the brake switch here, goes up and down. That's nice. On the other side, here's the ignition switch. It goes in the side panel here. And looking pretty good. So rectifier's mounted, ignition box is mounted. We installed the mag pickup for the ignition system, and Kevin installed that and set up the initial timing point, so that's done. All I have to do is connect these two wires to the wire that goes back here and connects to these two wires. So, and we've got that cable right over here in the box. So I'm going to call it a day and pick it up tomorrow, and maybe tomorrow I will even do a smoke test and hook things up and see what smokes. My bench is a mess. I may spend a little time putting things away, extra wires that have been cut out, just some of them. Let's talk about this. All the manuals on these Triumphs and other bikes call for a 35 amp fuse. Not really, guys, please. It's a Lucas 35 amp, but it's really 17 amps. Let's see if I can get a close-up of this for you. It's a Lucas 35. Let's see, can I get in here and show you this? All right, stand by. Where's that other one? Let's see if I can see this better. See where it says Lucas 35 amp. Well, not really. If you go a little farther, it's 17 amps. Okay, 17 amps. And I use 10 amps in these bikes. See, this one says 17 amps there. So it's not really 35 amp. It's a Lucas 35 fuse, and it's very confusing because a 35 amp fuse will stay in the circuit and watch all the wires burn to a crisp without blowing. So don't put a 35 amp American fuse in these bikes. Use a 10 amp. 10 is plenty. I do my testing with a 7, and then I send the bikes out with a 10 and a couple spares. And so anyway, that's the 35 amp. Wrong information. Wrong. Use a 10 amp fuse in your bikes. So over here I've got side panels here that'll go back on tomorrow. The air assembly, I'm going to buy new filters, and I should finish up this wiring tomorrow and do a test on it, and we'll see what happens. Okay, that's it for the day. I'm going to go order parts.